Nice. So last time we did regular traditional data binding in Angular, and today we want to go zoneless. We want to build everything with signals and get ready for the new era of zoneless development in Angular. Let's do the following. Let's create a new component that we can use to experiment a little bit with signals. ng generate component hello signals. We will do it in the following way. I'm going to demonstrate these signals using some, well, hello world signal demo component, and then I will ask you on your own to try to apply what I just told you on the one hand side on the number guessing example that I gave you last week, and on your tic-tac-toe example that you had as a homework and that we repeated in the previous hour. Okay, let's get started. Let's add a route so we can call our new fresh component. I will call it here just signals. And I will call it here hello signal component. And I will do it as the default route just to save some time. If I go to the browser here and I navigate to the root, I will go to signals. That looks good. Very nice. So let's try something very, very simple. Let's do an interpolation for a variable called counter. Let's create the counter. Let's start with 0. That will give us a very simple data binding. Now let's create a constructor. Do a set interval and simply increase the counter every second. This code will give us a ticking counter, as you can see. Works perfectly fine. I will give you a second to catch up. Nice. Okay, this works perfectly fine. And again, we can ask the question, how on earth does Angular do this trick? And now you should really already know the answer. It's based on zone.js. This is why Angular can detect that we change the variable in TypeScript. Here we have the variable, and every change is automatically propagated to the view because Angular is listening to events based on zone.js and therefore updates the counter. So now let's try something. Let's go into the app config ts. Here we are. And here you see that we have two methods which we didn't talk about yet in great details. Here you see provide zone change detection. You see, this is the magical spell which will make zone.js work, and everything should work out nicely. Now what happens if we comment out this line and instead say provide experimental zoneless change detection? See? Provide experimental zoneless change detection. The second thing that we do in Angular.js, in the config file of Angular, we are going to look for zone, and you see that there is a polyfill zone.js. Who knows what a polyfill is? Have you ever heard about polyfills? Typically, you talk about polyfills when you are extending the browser with capability that it doesn't have built in. So, for instance, if you have an older browser and you want to use a newer functionality of this browser, you're using a polyfill in order to simulate some functionality which is not built into the browser. And in this case, zone.js is extending the capabilities of the browser. Do you have a question, or did you want to make a comment?
No, it's fine.
It's fine. Good. So for now, you know what? Let's remove zone.js here in the polyfills area. Okay? We can add it later on. Good. Just to be sure, when I change something to AngularJS, maybe it's just me being paranoid, but I'm restarting the whole npm start thing. Probably it's not necessary, but yeah, you know, I just want to be sure. So let's reload the signals. And do you notice something? Do you see it? It's no longer ticking. Because now Angular has no possible way to recognize that we changed something in TypeScript. Therefore, it doesn't redraw. That's the whole point of it. So, if you want to have a simple life, if you want to take the blue pill, then just use zone.js. Many applications out there will stick to zone.js because they are very old and people are not going to rewrite them. But if you want to get the best possible performance in the future, you will probably, maybe not now, but in the next or the version after the next Angular version, you will go zoneless. Because then you get the best performance possible. So we achieved something. We had a perfectly fine application and we broke it. Yeah, question? Okay, I will come to you and help you overcome the problem. Okay, so we broke the Angular app. Let's make it work again. Now, how can we make it work? Very simple. We always give Angular a, pun intended, signal whenever something changes in our app. So what we are going to do, instead of saying counter is 0, we are going to say counter is a signal 0. Not hello signal. Signal. This one. See? However, if we do that, we have quite a few problems. First, we cannot simply say ++ anymore because the data type signal does not offer a ++ operator. That is not possible. Listen closely. If you want to set the value of a signal, you can say this.counter.set and give it some value. Let's start with 42, just for demonstration purposes. So remember, if you want to change the value of a signal to an independent new value, use set. If you want to manipulate the value of a signal based on its current value, you use update. There, you get the old value as an input parameter and return the new value as the output parameter. That is kind of ++ in the new signally way. So remember, signal, set, update. And if you want to display a signal on the screen, let's make it more general. If you want to read the value of a signal, you simply have to call it. So there is no get method, but the signal itself is a function that you can call, and it will give you the value, the current value of the signal. And you see something? It's ticking again without zone. Woohoo! That's the whole idea of zoneless development and signals. So let me open both files for you side by side, and you can catch up, write the code accordingly, and try if you can see the same behavior on your computers like on my computer. Let me repeat again, so you really remember what I tell you. Signal. This is how you create the signal. Set. This is how you change a signal and set it to an independent new value. Update is what you use to update a signal based on its current value. And last but not least, just call the thing to read it. I think so far we are good, right? Very nice. So let's try that. Think of our tic-tac-toe with an array. With an array, it's a little bit more complicated, right? So let's do some numbers. Typically, we would do something like this. And just to try it, we are simply going to say, again here, this.numbers equals to something like this. Well, we need to give it a data type. Let's say number array. And here, we just push the number. We just push the counter. I get an error. Why do I get an error? Line 20, what did I miss? Yes?
The call.
The call, exactly. It's a signal, therefore we need a call. So now we are just pushing values into the numbers. Let's display the numbers, okay? Let's say for n of numbers, track index, something like this. Let's do an unordered list. Give me a second, please, then I will answer your question immediately. Yep, this one. And then, come on. Then I'll do an li and display the number, something like this. So if we take a look at the Angular app, why does it work? Why the heck does it work? We are not using a signal here. Does anybody have an idea? Yep.
Maybe because it's an array.
Nope. Yeah.
Probably because, but maybe we have the signal when a signal changes.
Yeah, exactly. It's a side effect of the other signal. It's a side effect of the other signal, but it is wrong. The code that we see here, it works, but it accidentally works. It's wrong. We don't want to do it like that. I don't want to see something like this in your Angular applications anymore. So what we need to do is we need to change the data type. So here, we're going to say, give me a signal from this array. But the question is, how can we specify a data type for the signal? Answer, it's a generic method. So we can do it something like this. Here we say, I have a new signal. This signal is a number array. And then I specify the initial value. By the way, a signal must have an initial value. You cannot create a signal without an initial value. That's not possible. You could, if you want, do something like this. Did you remember? Do you remember union types? Then I can specify undefined as the initial value, but still that is an initial value. You must specify an initial value. So let's specify the initial value, which is an empty array. Now we can set this thing. That is the easy one. I mean, I just told you, just call set and we are good. Let's do the other easy thing. Why is this wrong? Everybody should now know the answer. Yes.
Because it's not called.
Exactly, it's not a call. It doesn't work like that. We need to do that one. So now we fix this one. But this is a little bit tricky. Numbers doesn't have a push method. We need to use update. But it is a little bit more complicated to update an array. Let me show you how it's done. We are going to say .update. Here we are getting exactly, I mean, GitHub Copilot does the trick. Let me zoom in and we will discuss it, okay? As you can see, the old value in this case is the old array. And then we are copying in with the 3 dots here, we are copying in the values of the old array and we are extending it. Oh, that is wrong. Should be like that. This dot counter, of course. We are extending it by adding the value of the counter. Does it make sense? This is the correct way how you update an array using a signal. Yes, question?
Is there no way to avoid all the heap allocations?
There is a heap allocation, but we don't care because there is a garbage collector. This is simply the way that you do it.
Okay.
So let's take a look. Works perfectly fine. Okay, I'll give you a second to catch up. Very nice. It seems to work everywhere. I'm happy. Now, let's take a look at what signal gives us. Signal gives us a writable signal. See that one? It is a writable signal that we get. Writable means that we can call set and we can call get. Get means I'm just calling the signal. So this is a writable signal. So if you want to specify the data type explicitly, you would have to say writable signal of number. You can do that. If you think that helps you reading the code, I'm absolutely fine with that. Some teachers in this school even demand to write the data type on the left-hand side. I don't demand it. It's really up to you. If you want to be explicit here, write writable signal. If you say that's perfectly clear for me, I'm fine with that, then use it like this. What you can do is you can specify read-only here, because that makes it very clear that this signal never changes. Don't get me wrong. The value of the signal obviously changes, but the signal itself remains the same over the course of the lifetime of this component. Got it? So this would be beautiful. If you forget about it during the exam, it is not a huge mistake, but this would be really beautiful because then you make it very clear the signal stays the same. Only the value of the signal changes. Let's check. It's still ticking, still doing its job. You have a question?
Yes. So are you also fine with implicit return types in functions?
Yeah, I'm fine. I'm fine. If you want to specify the data type, I'm perfectly fine. Are we good? Signals? Check. Very good. Next one. What if we want to create one signal which is based on the other signal? Imagine that we want to also display the length of the number array. We could do something like this. Read only, length of, let's say number of numbers. No, length, it's of numbers. This is good. And then we say signal, we start with 0. What we could do here, we could say this one, set numbers length. If we specify here the length in an interpolation, we will hopefully see 0, 1, 2, 3, works like a charm. But this is not a good solution. I will give you a second to try it so you can make sure that you really understood signals. But this is not how you should do it. We delete this line 21. We don't want to have it. We don't want it to be necessary to manually update the length of the numbers. Instead, we are switching from a writable signal to a read-only computed signal. Computed allows us to specify a rule with which the value of length of numbers is calculated. So here we simply say this signal, it's a read-only signal. If I hover over, you see it's no longer returning a writable signal, it's only returning a signal with an uppercase S, and that is a read-only signal. That returns a read-only signal which value is calculated by calling this .numbers signal getter .length. The rest stays the same. And if you take a look at the output, it works like a charm. Let me describe to you how computed works. Computed is at the beginning of the application called at least once. So Angular makes sure, hey, computed property, I need your initial value. Now this code is executed. Numbers, the number signal here is called inside of the computed signal. And then something very interesting happens. This call here recognizes that it's called in the context of a computed signal. And Angular internally remembers that the computed value depends on the value of numbers. So it automatically understands that there is a graph of dependencies. If something changes in numbers, it knows, oh, there was a computed property which depends on numbers, so I have to refresh this one too. That's pretty smart, isn't it? And those graph of those dependencies can become pretty complicated. So Angular is solving this complex, let's say, riddle in order to really update only those data bindings which are absolutely necessary to update. And think of a really complicated web application. You might have dozens, hundreds, thousands of these data binding expressions on a single page. And signals is the trick how Angular does this. Try it. Here we have the computed signal. Try to call it. Verify that it really works. Next step. So far, we set the values, we updated the values, we have signals, we have interpolation, but we haven't talked, bless you, we haven't talked about two-way bindings. So let's add maybe, I don't know what we are going to do. Let's add up there a little bit of HTML. Let's say we have an input. This is of type number. That's okay. And here we say we have a magic number, something like this. Exactly. Let's define the magic number here. Magic number equals to 42. And then we'll do a banana in a box binding here, ng modal, and we bind it to magic number. I hope you can remember from last week that this is a two-way binding. It doesn't work. Can anybody remember from last week why it doesn't work? What did I miss? Yes?
You have to import ng model.
Here, ng modal. Something like this. Cannot be imported.
What was it?
Can anybody remember what the correct thing is? You are right. It's in the imports, but it's not ng modal. Yes? Exactly.
Yeah.
ng modal is part of the forms module. So you were nearly correct. Yeah, fine. Isn't that fine? I mean, now we have something. Oh, I have to. Ooh. Let's here use a break and an horizontal line just to distinguish the two things here a little bit. Yeah, it's better. So let's change this one. And magically, it still works. See? But it is not the code that I want you to write. In this case, it works, yes. I'm thinking of a way to demonstrate how it doesn't work. Well, I don't care. That's also something that might not work as expected. It's simply and plain wrong if you do it like that. And now I have a very good news for you. ng modal is compatible with signals. So all we need to do is we need to say, this is a signal 42. And here we call it. Please, please, please. And this is a difficult one. I know it. You must not call magic number here when you use it in conjunction with ng modal. ng modal will automatically know that it has to read the value like this, and it has to set the value like this. Simply specify the signal, and it will automatically map both directions from here to here. That is the read-only call, and from input here to here, that would be the set call. ng modal does that automatically. That's brand new. That's also something that didn't work before. So feel lucky that you are learning Angular only now, because a few months ago this wouldn't have been so easy. So let's see if it works. Yep, works perfectly fine. Data binding works. I can do something like this. Works. I can enter a different number and it works perfectly fine. Let's make it beautiful by specifying again read-only, because it's a signal. We don't change the signal, we only change the value of the signal. So what's the point from what I just showed you? The point is two-way binding simply works. That's good news. Maybe you have expected that, but yeah, that's not old news, it's new news. New news. Okay, please try. There are even more new signal-based types that we are going to need, and I would like to demonstrate particularly one to you that is somewhat useful, but also very dangerous. So use it with care. What you can do with another signal-related functionality is you can listen to signal changes by using so-called effects. So what we can do in the constructor is we can call a method which is called effect. And then we can do something like this. For instance, console log counter. See? Now what is an effect? The effect runs at the very beginning again one time. So Angular executes the effect when the constructor runs. When the effect runs, it will again, give me a second, recognize that the effect depends on the signal counter. Got it? And then it will re-execute the effect whenever the counter signal changes. So if I take a look here, then you see if the counter changes, it's printed on the screen. This was the initial call, you see here. Then it recognized, oh, this effect depends on the counter, so I need to call it whenever the counter changes. And then Angular is smart and will call your code automatically if this signal changes. And that can not only be done with signals, but also with computed signals. So if we change that a little bit, I can simply say length of numbers, and it still works. And now it's getting pretty interesting, isn't it? Now we have an interesting dependency tree, if you want, a dependency graph would be more correct. We have numbers. This numbers is used here. So computed has a dependency on numbers. This computed property, this computed signal, is now used inside of the effect. So the effect has indirect a dependency to numbers. Got it? And this is exactly what this whole thing is all about. This is why it's not a trivial thing to implement. You had a question.
I was going to ask if it was similar to the computer.
It is similar to the computed, but the effect doesn't return a value. So the computed signal is automatically recomputed when the original signal changes. The effect is re-executed, but the effect does not return something. Okay. Now I'm doing something horrible. Please don't try that at home. Yeah. Forget it immediately after I now change this code. I'm going to do something like this. Now the computer will halt and catch fire. Obviously it doesn't work. If I try to do that, boom, I immediately get an error. Writing to signals is not allowed in computed or effect. This means whenever we are in a computed signal or in an effect, we are not allowed to alter a signal. We cannot set a signal, we cannot update a signal. That's simply not allowed. Why? Let me show you why. We can say, hey Angular, I know what I'm doing. I really know what I'm doing. I want to allow signal writes. So I can force Angular to allow to do that. And now, well, things aren't as bad as I thought. Why aren't things as bad as I thought? Well, in this case, it kind of works. I expected a more critical error. Let me reload this thing.
Maybe if you use the counter.
Now, take a look at here. Here you see it. See it? No, this is what I do. So, let me see. 3, 5. The problem is, the problem is that in this case, I have an effect. This effect changes numbers. Numbers changes the length of numbers. Length of numbers triggers the effect because we print it here. But because the effect will again add something to numbers, numbers will trigger the effect again. So we are in an endless loop. In this case, it's not coming to an endless loop. Angular is somehow recognizing it. I'm not 100% sure why, but at the end of the day, this is definitely wrong. You should never, ever, ever, ever do that. It's wrong. You shouldn't do it. Let me try it in the different order. Maybe then we have... Yes, now I have it. This is what I meant with halt and catch fire. You see? Now we have it. I love it when a plan works. You see, now I'm executing the length of numbers, and then I'm changing the numbers, which will trigger another effect run, which gets to the length of numbers, and I think you get the idea. We have a classical endless loop. And this is exactly why this is dangerous. And this is exactly why Angular is by default preventing us to update signals in an effect or compute it. So it's a security measurement. You can't disable it, but yeah, you gotta be good if you want to be bad. So you gotta know what you're doing. We have some questions. Yes, please. You need my help? I will come to you immediately. Okay. Now we solved some. Yeah, I have another question. Yeah, come on. Just to make it very clear, in this course, it is not our goal to remove zone.js. I just wanted to demonstrate to you how you can try this feature. The Angular team themselves say that some parts of Angular are not ready for being zoneless. Tools like Bootstrap for Angular, tools like Material for Angular, they are not 100% zoneless yet. So I would say be careful when removing zone.js. In your exam, I will not ask you to remove zone.js. That's not necessary. It's very experimental and it was for your interest, so you saw how it works. Still, we are already now going to use signals because that, even if you stick with zone.js, makes your Angular application faster. So we are preparing for a world of zoneless development, but we are aware that Angular isn't fully there yet. This is why the method is called provide experimental zoneless block. Okay, it's just a very early experimental. Angular 19, Angular 20, and then we will probably be able to safely remove zone.js. But for now, it was just a demo. When we go to the exam, homework, and so on, you do not need to remove zone. Good? Very nice. So that was my introduction for you related to signals. Now we can practice a little bit. I want you to take the example from last week, which was the number guessing component. If I were in your shoes, I would copy this component or create a new one and simply create exactly the same component, but this time 100% signal-based. And then try the same with the tic-tac-toe. Take your tic-tac-toe and make it signal-based. If you didn't, let's say, finish your homework, then you can take the quick implementation that we drew together today in the morning as a recap of what we did so far. Okay? Very nice. So, it's time to exercise. Okay, I hope your practice time with signals was a little bit or completely Successful. I got some questions. Do we have any urgent questions at the moment regarding signals? Good. I would like to demonstrate one additional thing today about Angular. We are talking about Angular services. Services aren't really complex to understand, and let me quickly describe what services are. Imagine that in our tic-tac-toe component that we implemented today in the morning, we have this method which is called getWinner, which returns a winning status, as you can see it here. It is currently depending on the board, as you can see it here. It doesn't get any parameters, and I would like to change that. That's the first preparation for introducing a signal. Please change it so that the board is now an input parameter. So just like the board up here, it will be just the cell content. Here it is. Here we can pass in the board as a parameter, and then it should be possible to make this thing static. Wherever we have this.board, we remove this so that we use the input parameter. Yeah, and now it should work again. And it's no longer called getWinner, but it's called tic-tac-toe component.getWinner. Now it should work. By changing this design of the method a little bit, we make our winner detection independent of the tic-tac-toe component. So theoretically, and I know it's very theoretical, but let's just pretend that we have multiple different versions of a tic-tac-toe component. Maybe we do a very simple tic-tac-toe, we do a graphically enhanced tic-tac-toe, maybe we do a tic-tac-toe which is three-dimensional or whatever, but all the different tic-tac-toe implementations need the winner detection. And by making it static, as you can see here, we made it independent of this class. We can now theoretically call it from wherever we want. And exactly in those situations where you need logic, which is not tied to a single component, but which should be available throughout the entire application in all components, exactly in such situations, we use services. Let me show you how this works. First, we create a service. It works very similarly to creating a component. ng generate, but this time we don't say a component, but we say service. And then we say we create the tic-tac-toe winner, not service, because otherwise you will end up, you know it, with a tic-tac-toe winner service. So let's call it tic-tac-toe winner and generate the service. If you do that, you will get a new file. Here you see it, tic-tac-toe winner.service.ts. And the tic-tac-toe winner service is a plain class, nothing special. The only thing that is a little bit special is that we have this @injectable up here. It's a decorator that simply turns the class into an injectable service. Have you heard about dependency injection before in previous classes? Yeah, I see you nodding. Okay. Injectable adds our class to Angular's dependency injection system. Okay? Good. Now what we are going to do is we are going to take the getWinner service, the getWinner method, cut it from tic-tac-toe component, and put it into the tic-tac-toe winner service. We will also migrate the cell content and winning status type from this file. I will simply take all these types here, I will cut them and put them here and export them. Now we have a plain class which contains business logic that might be useful for multiple components. And that's the whole idea of these services. It's just a class that offers, as the name suggests, a service to many other components. That's the idea. You enhance reusability. Now the question is, how can we use this service in the tic-tac-toe component? Very simple. Well, first, let's get rid of these errors. Cell content, we simply have to import that. Player, we simply have to import that. And now we need the service. And it's very simple to get to the service. Let me show you that. We can say the winner service equals to, and now comes the new thing, inject tic-tac-toe winner service. Whoops. Now it's better. Inject is the function that we are talking about. Inject means, hey Angular, take a look. Somewhere is a tic-tac-toe winner service. Please get it for me. And that will give you an instance of the tic-tac-toe winner service. This is what you need to remember. Inject tic-tac-toe winner service. And now we can use here the winner service dot get winner. And I forgot something. I'm sorry. I need to make this public. Otherwise, I cannot access. And with that, it should work. It doesn't work. Oh, sorry. I made a syntax mistake. I'm super sorry. Please. I'm super sorry. This is the correct... No. No. I screwed up something. Let me quickly check what I did. I'm so stupid. In a service, you don't want to have the method static anymore. And I will describe in a second why this is the case. So here we say this dot winner service dot get winner, and now we are good. Sorry for me being confused for a second. So now we have it correct. As you can see, this is a class. It offers some methods, like in this case, the get winner method, and it can be injected in every component that benefits from this service. And then you can simply call the methods. Again, what is the reason for a service? The reason for a service is that you have logic that is used by multiple components. Got it? There is one additional big advantage of services. If multiple services use this inject method to inject a service, they all get a reference to the same instance. So the service is created as a so-called singleton. Have you heard about singletons before? This is a singleton. You know why this is important? Imagine that you would like to implement a caching service where you store some values in memory so you do not have to fetch them from a database every second or so. It's important to have a single cache, otherwise the cache wouldn't have a purpose. Understood? So it is important to understand that if you use inject like this, you will always get a reference to the same instance of the service. Was it necessary? Give me a second. Was it necessary for this example? Do we benefit from the service here? No, because we do not use the service in multiple components. Please excuse that. I want to teach a tool to you. I want to show you a tool that you will use later on in more complicated applications. As soon as you have an application that consists of many components, and I know of Angular applications that consist of hundreds, if not thousands of components, you will need services in order to share data and functionality between them. Recap. ng generates service to encapsulate services that are used by multiple components. Next, a service is a plain class, as you can see it here, with the injectable decorator. And last but not least, use the inject method of Angular in order to get hold of an instance of this service. Now we have questions.
Is the
Very good. Now I have an exercise for you. Let me show you this exercise. This is a nice exercise for Angular. It's a Morse encoder and decoder. You all know the Morse alphabet? Yes, no? Yeah. So this dots and dashes and things like that. So what I would like you to do is I would like you to implement an Angular application for encoding and decoding the Morse code alphabet. And I will give you the details now.